Hi, we're the Consumer Product Manufacturing Enterprise, or CPM. CPM consists of a diverse set of projects, each tasked with solving a problem with a real-world consumer product or process. Each project team uses engineering principles to achieve innovation and improvement, ranging from increased productivity and quality to reducing operation costs and to promoting sustainability. CPM teams are multidisciplinary, including combinations of chemical, mechanical, and biomedical engineers. Many of our projects are brought to us by industry sponsors, while others are student-driven. Our projects fall into three key categories: consumer innovation, process improvement, and sustainable service. The next segments of this video will include project overviews from each of our CPM student teams.
Hi, we're the Combustible Dust Hazards Project with CPM. I'm Katie Lieberman, the team lead.
I'm Zach Maurer.
I'm Dominic Heston.
I'm Dylan Chasky.
As chemical engineers, we're utilizing our knowledge of design and analysis to be able to excel in our projects.
Our sponsor for this project is H.B. Fuller, who is the world's largest adhesive-only manufacturer. We work with Peter Montagna, who is the World Director of Process Safety.
And our goal this semester is to measure charge accumulation to assess the hazards of pouring dust into mixing vessels. Use this vessel right here to measure the charge accumulation, and this humidifier to adjust the humidity level within the vessel.
The focus of the semester so far is to test cornmeal at various humidity levels. We test the voltage, and we find that with higher humidity comes greater charge dissipation, and we'll be testing other materials soon.
Hey, we're CPM's biogas team. My name is Colin.
I'm Kaden.
I'm Abby.
And I'm Anya.
And we're all chemical engineering students.
So the biogas team's objective is to construct a pilot plant to evaluate the feasibility, benefits, and requirements of a full-scale anaerobic digester.
This project aims to reduce MTU's environmental footprint and produce methane as a renewable fuel source.
This semester, the team has focused on equipment upgrades for the plant.
We've worked on welding a new base to support the plant, designing and building a bench-scale biogas plant, and testing the time it takes for our bacteria to begin producing gas.
Hi there, we are here representing AAA Prosthetics, with the rest of our team being listed here, and the goal of our project is to create a mechanically simple foot and ankle design at a low cost for low-income communities. This semester, we redesigned our foot. This is what it currently looks like. It is called the rubber ball design. We also recreated a walker, which we use to test the gait.
Hi, we're CPM's Koppers Chemical Analysis Team. I'm Sam Cox, the team lead and chemical engineer. Our other team members are Wyatt Madden, Colin Meinholz, and Margaret Roland, all also chemical engineers.
Our project is sponsored by Koppers Performance Chemicals. They are one of the world's leading manufacturers in wood-treated products.
The goal of our project is to develop an inline chemical analysis setup for more efficient wood treatment chemical production.
And this spring, our focus is to use a UV vis spectrophotometer to measure the amount of copper in solution.
We are POC.
The Portable Oxygen Concentrator project focuses on creating an oxygen concentrator capable of producing 99% pure oxygen at a rate of 5 liters per minute.
The team has completed extensive research and began construction of our second sieve-bed prototype seen before you. The goal of the prototype is to determine the Langmuir absorption process of the Z-vents to determine the optimal amounts to use in our prototype that will utilize the pressure swing adsorption.
And this is the Clean Diesel team. This semester we've been building a small unit to kind of increase the production of our scale from lab scale to bigger size, and we've been running some titrations in the fume hood on our waste oil. Yeah, thank you.
Hello, we're the GSK team on the CPM Enterprise. I'm Max Blake.
I'm Cameron Rumber. I'm Daniel Reynolds. I'm Robbie Peabody.
And I'm James Patterson.
The goal of this project is to detect chloroform in the waste streams of GSK's cleaning process.
In order to accomplish this, we have been running our tests through a UV vis spectrophotometer after undergoing the Fujiwara reaction, a reaction in which chloroform and pyridine react to produce a red wavelength at about 365 nanometers.
Using this data, we intend to produce a calibration curve that GSK can use to determine the concentration of chloroform in their wastewater.
So that was an overview of each of CPM's active projects. Some projects, such as Koppers, will conclude project work this semester and provide final recommendations to sponsors for industry implementation. Others will continue into future semesters and will be joined by new projects proposed by both prospective sponsors and inspired students. For a more in-depth look at CPM's projects, please visit our booth at the Michigan Tech Design Expo. Thank you.